Okay, in lesson 8.1, we're going to start a whole chapter of 8 on powers and exponents. And first, let's just take a little look at some of the vocabulary. So a number that can be expressed using an exponent is called a power. The base is the number that is multiplied. And the exponent tells us how many times the base is used as a factor. So in this 5 to the third power, the 5 is the base, the big number is the base, the 3 is the exponent, and the whole thing is the power. And then we know that that means we're supposed to take 5 times 5 times 5, which would be 125. The most common mistake is probably to accidentally do 5 times 3 and get 15. So we want to slow down enough to remember it's really 5 times 5 times 5, 125. To write expressions using exponents, we would take the base, so the big 3, and then count up 1, 2, 3. So that would be 3 to the third power. And for the next one, the base is going to be a t, so we would have t, and then 1, 2, 3, 4, 5. So it would be to the 5th power. In example 3, if there are different bases, we just have to do each one of them separately. So the 6 we just leave as a 6, and then we'll see a times a could also be written as a to the power of 3. And then we'll use the base of b, and it would be b times b would be b to the power of 2, or it could be called b squared. And a to the power of 3 could be called a cubed. To evaluate exponents, we are going to just do 2 times 2 times 2, and we're going to get 8. If you wanted to do that on your calculator, you could do 2 to the power of 3. And on the graphing calculators and on a lot of calculators, it's this button that looks like kind of an upside down V. It's called a caret. And then on some other calculators, you'll be looking for a button that looks more like this, y to the power of x, or sometimes it says x to the power of y. It could be either one of those. And you would put in the 2 and then hit that button and then the 3. So for number 2, the negative 3 is in the parentheses, so that means we'd be doing negative 3 times negative 3 times negative 3. And when we're multiplying, negative signs cancel each other out in pairs. So those 2 would cancel out. We'd still have this one leftover negative sign. And 3 times 3 is 9, times 3 is 27. So that would be the answer. If you did that on your calculator, you would absolutely have to have the parentheses around it. And actually, if it's an odd power like this one, it would work even without the parentheses, but it's going to be a really good habit to use the parentheses, because if it's an even power like our next problem, it won't come out right it won't come out right on your calculator unless you do the parentheses. So let's take a look at number 3. So this actually means negative 4 times negative 4, and when we're multiplying, pairs of negatives cancel out and we would get a positive 16. And if you type into your calculator negative 4 squared without the parentheses, you're going to get it wrong. It will say negative 16. So if you're using your calculator, you'd have to be sure to put the negative inside of the parentheses and then put the exponent afterwards. And then you're going to get that right. It'll come out to be a positive 16. And we can see why, because it means negative 4 times negative 4. Okay, the next one, it doesn't mean the same thing. This one just has a negative sign sitting out in the front, and then the power is really only on the 4, so it's just 4 times 4. So we're going to keep that one negative sign, and the answer would be negative 16. And this time, there's no parentheses, so if you put it in your calculator, you would not put in parentheses because they aren't there, and you would get a negative 16. We're only squaring the 4, and then the negative gets put on afterwards. Well, in the next problem, if we were doing it by hand, we would do order of operations, and we would do the exponents first. 4 times 4 is 16. 25 minus 16 is 9. Or you could just type it in your calculator, and you would get 9. Okay, in this next one, if we are going to square a negative 3, so I would be doing negative 3 times negative 3, and that would turn into a positive 9, and then we would add the 5 and get 14. And now here, even though there's no parentheses right here, we would need to put them, or when we substitute the -3 in place of the y, we would need to put the parentheses around the -3 if you were doing that on your calculator, because you want your calculator to know that you're squaring the number and the negative sign. And then you would get 9 plus 5, the calculator would get 9 plus 5 and get 14. If you don't use the parentheses, you're going to get it wrong. Your calculator is going to think that it's -9 and it's going to give you -4, and that is wrong. So just be really careful to put parentheses around negative numbers if you are raising them to an exponent. Okay, so now we're going to learn a property about powers, and it's called the product of powers, and here's what it says. If you're multiplying powers that have the same base, you actually end up adding the exponents. And so that feels a little weird because, like in this problem, we're doing a multiplication problem, and notice the base doesn't change. We don't do 5 times 5, we just leave it as a 5, and then we add the exponents together. So that answer would be 5 to the power of 5. I'm going to show you why that's the way it works. So here I would have 3 to the 4th means 3 times 3 times 3 times 3. That's what 3 to the 4th is. And then 3 squared means 3 times 3. And then the problem says I'm multiplying them, so I just put a multiplication in the middle. And now look, I have this whole long list of 3's, and that would be the same as 3 to the power of 6. So it's like we're just stretching out these lists and counting up how many things are in the list. And we keep the base the same because it's just a whole bunch of 3's. So in the next problem, it would mean x times x times x, and then x squared is x times x, and then we're multiplying those, and we would get x to the 5th power. In this one, we're just going to add up the exponents. We don't really have to write out the list every time. We can just use the little rule, and this would be x to the power of 6. Because when we don't see an exponent there, there's really a 1 there. Okay, so for this one, we have a whole bunch of 3's lined up, and if I count how many, it would be 1, 2, 3, 4, 5, 6, 7, and then this last one would be 8. So this would be 2 to the power of 8. And that's how you'll enter it in Schoology, just put 2 to the power of 8. You could figure out what 2 to the power of 8 is. I'm going to put that in my calculator, and I get 256. You could do that, but you don't have to. You can just leave it like this. And if the directions say write it with exponents, then you have to leave it like this. Okay, now in this one, the -3 is in parentheses. Leave it in the parentheses, and then add up the exponents, and it would be to the power of 6. And if you wanted to take off the parentheses, you would also have to take off the negative sign, because this is an even number. And so if you think about, if we laid it out, -3, like if I laid out 6 of these, I'm going to be multiplying 6 of them, all of the negative signs would cancel because they cancel in pairs, and there wouldn't be any negative sign left over. So you could answer it this way with parentheses or this way without parentheses. Okay, so in this one, you can leave the -4 in the parentheses and add the exponents and just leave it like that. This time, if you wanted to take off the parentheses, you would keep the negative sign, because if I had 7 of these lined up, the negative signs would cancel each other out in pairs, and there would be this 1 extra negative sign. So we'd need to keep it, and it would be, this would be fine with parentheses, this would be fine without parentheses. They're going to give us the same answer. And that's because this is an odd exponent. So it depends on whether the exponent is even or odd. The safe thing to do is just leave it in the parentheses, and then it will be right every time. Okay. All right, so for this problem, it is multiplication. So since these are just normal numbers, I can multiply those. 5 times 3 is 15. And then to multiply the t's, I actually just add the exponents. Because this problem, if I stretched it all out, it means 5t times 3 times t times t, because that's t squared. And so you can see we'd get 15 and then t to the 3rd. Okay, so in this next problem, number 8, the 8 is the regular number, just leave it like that. Then I'm going to count up the a's. Here's one a and two more a's, so that would be a to the third. And then altogether there would be 10 b's, 5 plus 5. Even though it's multiplication, we're adding the exponents. Okay, so in this problem, it's all multiplication, and I can just multiply the -4 times the -5 and get 20. When you multiply two negatives, we're going to get 20, a positive. And then I'll count up that there would be 4 x's, because I have to count that as 1. And then there would be 5 plus 3 would be 8 y's. Okay, and then the last thing is if we're looking for a missing exponent. So I'm just trying to figure out what would go in this spot right here. And in order to get a 10 over here, it would have to be a 6, because 4 plus 6 would be 10. And then for this one, trying to figure out what would go in this spot. So I have one x, and I end up with 5 x's. So that would have to be a 4 in that place, because 1 plus 4 would be 5. So even though it's multiplication, we do the problem by adding the exponents. Okay, don't forget to send me a picture of your notes if you're in the IMC.